Hello students, I hope you all are fine. Today we will discuss about physical properties of benzene. Yesterday we discussed about method of preparation already, how can we prepare benzene, we already discussed. Today physical properties. Students, benzene, this one is the structure. There are 6 carbons at alternate position. Double bonds, pi bonds are there, and at each carbon hydrogen is also attached there. C6H6. You know very well students, here bond between carbon and hydrogen only. Here bond between carbon and hydrogen only. These are the carbons. There are bond between carbon and hydrogens. And you know very well, carbon-hydrogen electronegativity difference is negligible. Electronegativity difference of carbon and hydrogen is negligible. It is not so much. Then students, we can consider benzene as non-polar compound. Because if electronegativity difference will be there, then more electronegative element attract electrons towards itself and it get negative charge on it. And other, which one is less electronegative, attain positive charge. But here electronegativity difference is negligible. So positive negative pole will not develop here. That's why it is the non-polar compound. Clear or not? Students, these aromatic hydrocarbon may exist in gaseous, liquid or solid form. If number of carbon atoms will increase, then their state will vary. Okay, if less number of carbon atom, then they will be in gaseous state. If carbon atoms will increase, then convert in liquid and in solid. Clear? If I talk about their color, they do not have any specific color. So we can say they are the colorless. Okay. And students, they have smell. They have some specific odor, smell, or we can say odor. You can see naphthalene balls. Naphthalene, already I told. Naphthalene means 2 benzene rings. Naphthalene balls. Students, for prevention, or we can say for preservation of our clothes from insect, we put some naphthalene balls in box in which we are putting our clothes. Yes or not? Yes. We do. Why? Because naphthalene has smell. Due to that smell, insect do not come closer to those balls. Clear or not? So insects will not enter there, and we can prevent clothes from insects, from germs. Clear or not? And if we store some grain, some wheat, okay, for long time, then also we use some balls there. So why? Due to their smell. Clear? So they have odors. They have specific odor. If I talk about solubility already in case of alkene we discussed. Always like dissolve, dissolves Like, means polar will dissolve in polar, polar will dissolve in polar, polar dissolves polar, and non-polar dissolves non-polar. We say solubility in water because water is the universal solvent. Water is the universal solvent. Okay. If we talk about solubility of benzene in water, then it is not miscible. It is not miscible, or we can say immiscible with water. Immiscible with water. Immiscible means it will not dissolve in water. It will not dissolve in water. Why it is? Because water, H2O, it is polar. It is polar. Water is polar. But our benzene already I told, our benzene non-polar. Benzene non-polar. So they have opposite nature. They have opposite nature. So they cannot dissolve. They cannot dissolve. So benzene cannot be dissolved in water. It is immiscible. Immiscible means cannot dissolve in water. And miscible means which can completely dissolve. Like student, if I dissolve salt in water, so it can dissolve at all proportion, na maximum. So it is miscible. If I dissolve alcohol, ethanol in water, so it can dissolve easily because both are polar. Clear or not? Then they known as the miscible. Immiscible means they do not dissolve. They do not mix with each other. Clear or not? Why? Because benzene is non-polar, but water is polar. So both are having opposite nature. That's why they do not. Benzene cannot dissolve into the water. Okay, but it can dissolve in other non-polar organic compounds. Non-polar organic compounds. Like acetone, like ethanol also they can dissolve at some proportion. Means in other non-polar organic compounds they can dissolve. Clear or not? Any doubt? Yes. They burn with sooty smell. If we burn benzenes and other aromatic hydrocarbon, then they can burn with sooty smell. Means bad type of smoke they release, and with bad smell also, unpleasant smell, which we cannot, in which we do not feel comfort by smelling. Clear? Means unpleasant smell they produce. Clear or not? So this is all about the physical property. They may be solid. If I talk about the state, then they may be solid, liquid, and gaseous. It will depend on number of the carbons. They are non-polar. Because they are non-polar, so they cannot dissolve in water. Clear? They can dissolve in non-polar organic compounds. Then students, chemical properties. Chemical properties. It is most important. As it is same reactions, you will read in 12th class as it is, without any change. Chemical properties. Students, aromatic hydrocarbon show electrophilic substitution reaction. Electrophilic substitution reaction. In alkane, you discussed about nucleophilic substitution reaction, in which one nucleophile substitute others. But here you are discussing about aromatic hydrocarbon, benzene. Benzene shows the electrophilic substitution reaction, in which one electrophile substitute other. One electrophile substitutes other. Clear or not? How? First one is the chlorination, or we can say halogenation. halogenation. If we have benzene, this is benzene. Halogenation means react with halogen, addition of halogen. If we have halogen and we do reaction in presence of anhydrous aluminium chloride or anhydrous FeCl2, any one condition we can follow. Then student, what will happen? We will get chlorobenzene plus HCl. Try to understand first. Here at each corner, at each carbon, hydrogen is present. Hydrogen is present. Then at the place of this hydrogen, this is substituted by one chlorine. One chlorine. Now hydrogen is not there. If I write benzene in this way, there are 6 carbons. 6 carbon. 1, 2, 3, 4, 5, 6. At each carbon hydrogen, one bond, it is forming with hydrogen. And alternate double bond.
Plus R students. Where they are?
Okay. Then alternate position. So at each position, at each carbon, hydrogen is here. But here we are getting chlorine instead of this one. So here hydrogen is replaced by chlorine. Hydrogen is replaced by chlorine. Okay. And this one is the electrophile. How it is, I will explain about that. So here students, substitution take place. Chlorine is substituting hydrogen. That's why it is known as the substituted reaction. Okay. Here H positive substituted by Cl positive. H positive substituted by the Cl negative. So Cl positive, why it is? You will see. Actually, you are having Cl2. I can write in this way. You are having anhydrous aluminium chloride. Aluminium chloride, AlCl3. Aluminium has only 3 valence electron and it is forming 3 bonds also. But it is Lewis acid. It is electron deficient. Only 2, 4, 6 electron here. But for getting stability, there should be 8. Okay. So student, it need electrons. From where it can get? For taking electron, it will break this bond. It will break this bond. Clear or not? Then what will happen? It will attract these towards itself. If it will attract, then this chlorine lose its electron, so Cl positive, and this Cl negative and AlCl3 already means formation of AlCl4 negative take place. Yes or not? So in this way, chloronium ion form. Chloronium ion form. We know very well chlorine is more electronegative element because it is halogen. But after becoming more electronegative, positive charge is here. Which one making it highly unstable? Which one making it highly unstable? Now students, it need electron. It need electron. From where it can take? Means we have electrophile. Electrophiles are electron loving. Our electrophile is chloronium ion. This Cl positive is known as the chloronium ion. If Cl negative, this is chloride ion. This is the chloride ion. But here generation of electrophile take place. This one is the chloronium ion. Then students, from where it can take electron? It can take electron from benzene ring because availability of pi electron here. Availability of pi electron here. What will happen? This bond can shift here. Yes or not? Resonance, you know na? Then what will happen? Hydrogen present at all, you all know. Hydrogen present at all, you all know. Then, sorry. This bond shift here, this bond. So here, negative, this hydrogen. We are not doing anything here. If it is losing, then positive charge here, clear. So students, this one hydrogen can support this bond, can support this one carbon na? Yes or not? If it will support, then this bond shift here, so positive negative cancel each other. Now no charge here, but here negative charge, here negative charge. If it will support this one, then chloronium ion you are having na, chloronium ion you are having. This bond, this one bond you can shift here, it can support this one, clear. Then this double bond further came, and here negative charge, so positive negative make bond with each other. So from here H positive is removing or not? H positive removing, plus AlCl3 be having like catalyst only, so Cl negative also there, plus Cl negative. So what will form? Chlorobenzene plus HCl. Chlorobenzene plus HCl. It is clear or not? Here we are having benzene. In benzene, in presence of chloronium ion it happen. In presence of chloronium ion it happen. Chloronium ion needs some electron. That's why shifting of electron take place. Okay, so it can get electrons from double bond only. Shifting of these electron will take place here. If shifting take place here, then this bond, this double bond shift here. So negative here. Now, this one hydrogen can support this one, okay, and this chlorine, positive and negative can form bond. So finally you will get double bond here, Cl and H positive, and H positive and Cl negative will form HCl. Clear or not? Any doubt in this? Yes. But students, try to understand, if you write same reaction, benzene you are having, you want to do chlorination. This reaction you will do in presence of anhydrous AlCl3. Anhydrous AlCl3. So electrophilic substitution reaction take place. So here chloronium ion H replacing, it is substituting hydrogen, and from here H plus and Cl negative, removal of hydrogen chloride take place. This reaction is clear or not? Here substitution take place, and substitution of which? Electrophile. That's why it is known as the electrophilic substitution reaction. But student, if you have substituted carbon, like this, if you have benzene, toluene, chlorobenzene, then you want to do this reaction. You want to do chlorination, electrophilic substitution. In presence of anhydrous AlCl3. Then this chlorine, where will you attach? Then you get ortho-para directing compounds. Ortho-para directive products. What do you mean by this one? You will do reaction in same way. Toluene, this chloronium ion, you will attach at ortho position. Ortho position is 1-2 position. Ortho position is 1-2. Either at ortho or at para. Para is 1-4 position. 1-4 position. You will get mixture of ortho and para. Ortho and para. You will not get meta. You will not get meta. Why it is? I will tell. Here students, this chloronium ion, either you will attach to ortho or you will attach to para. You will not attach at 3 position. You will not get meta product. Okay. And here, in between these, this para is more, or we can say major, and this one is the minor. This one is the minor. Now why it is? You are having CS3. Student, try to understand. If this release electron, this release electrons. Okay, then students, electrons where come? Already you have made structure for resonating structure of the chlorine, chlorobenzene, because you already discussed about them. Here, this come here and this shift here. Resonating structure, you know very well. So either if this shift here, then plus double bond, and this shift here, negative. Clear? Then you will shift this one here and this one here. If you will do Badal Cl plus, this bond here and here negative, means you can see electron density. You will try to make resonating structures. When you will draw resonating structure, then electron density increases on ortho and para position only. In resonance, electrons comes at ortho and para position. Okay, and here student, this electrophile need electrons. Electron, from where it can take, where availability it get. Okay, because availability of electron it is at ortho and para position, not at meta. Clear? That's why it gives us ortho para directing compounds only. And why this one is the more stable, this one is the major product? Because students, here symmetry, already these two groups are present at maximum distance. So further repulsion will be minimum. Further repulsion will be minimum. And students, here, due to the symmetry, this is the major product. It is the more stable. Here, they can repel or not?
Yes.
Clear or not? So, if you have substituted hydrocarbon, okay, aromatic hydrocarbon, and you want to do electrophilic substitution, then students, you will get ortho and para directive compound. And in this para will be the major product. Clear? Some more examples of electrophilic substitution reactions are there. We will discuss about them tomorrow. Today we have done only one. Simply we will substitute. First of all, you will identify. First of all, you will identify electrophile only. Like in Cl2, here in presence of anhydrous Cl3, formation of electrophile Cl plus take place. Then you will attach that electrophile. If only benzene, so at any position you can attach. But if already substituted hydrocarbon you are having, then you will attach that electrophile either at ortho position or at para position, and here this para will be the more stable compound. Clear? So thank you. Have a nice day.